This is for educational purposes. This is from the 2007 exam, Form B, question 4. So let's see what we have. We have a graph here. That graph is a derivative graph. And here we go. So no calculator. It says, let f be a function defined in the closed interval between -5 and 5 with f of 1 equals 3. Okay. The graph of f prime, the derivative of f, consists of two semicircles and two line segments as shown above. All right. Between -5 and 5, find all values of x at which f has a relative max. Justify your answer. Well, I'm looking at f prime, and f is going to have a max whenever f prime changes from what to what? Positive to negative. So it could be possible here, and it could be possible here. Does that make sense? So there it is, and it just wants me to list all x values and then to justify my answer. So I'm going to say f has relative max at x equals -3 and x equals 4 since f prime changes from positive to negative at those specific x values. And there it is. So that's letter A. That gets us the cred. We're okay? All right, letter B. Between -5 and 5, find all values of x at which the graph of f has a point of inflection. Justify your answer. Well, I have f prime, so you want to reference f prime. F has a point of inflection whenever f prime changes from what to what? You guys remember? Points of inflection. F has a point of inflection whenever f prime changes from... No, not positive to negative. That's a max. That's where f has a max. Where f prime changes from... Well, that's what I'm looking for. Where f changes concavity. Points of... So where f prime changes from what to what? No, not from concave up, concave down. That's where f point of inflection is where you change from concave up to concave down or vice versa. I'm looking at f prime. And be specific where what changes from increasing to decreasing? F prime. So I'm going to say, so let's see. Where does f have a point of inflection? I have a point of inflection at -4. I have a point of inflection at -1. And I have another point of inflection at 2. So there it is. F has points of inflection. You could have also said where f prime has extrema. At x equals -4, comma, -1, comma, and 2, since f prime is changing, and I like to state the first one first, is changing from increasing to decreasing and vice versa at those specific x values. Does that make sense, guys? All right, f has a point of inflection -4, -1, and 2, since f prime is changing from increasing to decreasing, and vice versa at those specific. Yep, perfect. All right. Find all intervals on which the graph of f is concave up and also has a positive slope. So I want f to have a positive slope and concave up. So you see this graph right here? I'm only looking at this curve that I'm above the x-axis because that means that f has a positive slope. And they want, what if they want? Concave up. So that means that f prime needs to be what? Increasing. So here it is, this in blue, and this one in blue. Do you guys see those intervals? So I'm going to say f has a positive slope and f is concave up on the interval So this interval, guys, is going to be parentheses, no brackets. -5 to -4. And 1 to 2. And it says, explain your reasoning since f prime is what? It has two things, positive and increasing, for both. Since f prime is positive and increasing on these specific intervals. So there it is. Are we okay? All right. Find the absolute minimum value of f of x on the closed interval -5 to 5. Explain your reasoning. Okay. So I'm going to get my endpoints and I'm going to test my critical points. I'm going to do a candidates test, just like we've been doing. So I need to find where f prime is 0. So f prime is 0 at -3 and at 1 and at 4. You guys see that? And then I'm going to test my endpoint. So I'm going to write x and I'm going to write f of x. And then I'm going to go, let's see, what's my endpoint? -5. And then -3. So let me go ahead and write where f prime is 0 first. F prime of x is 0 when x is -3, comma, 1 and 4. 1 and 4. So -3, 1, 4, and then my last endpoint is 5. I don't have to do, they wanted absolute minimum. Do you guys see that? So I don't have to test the 3 one and the 4 one. Why? There's maximum. So state that. Put it in here. Put max or local max. Technically, everything's a local max. So I'm not going to do it. I'm going to put NA. And then the 4 one, I'll put NA. And I'm going to put local max. That way we don't have to do more work. Now, which one do they give us? So look right here how they give us 1. Do you guys see how they give us 1? So I'm going to put f of 1 equals 3. So put 3 right there. So that means I need my -5 and 5. All right, here we go. I'm just calculating it, guys. This is like finding position. So f of -5 equals f of 1 that they give us, f of 1 plus the integral from 1 to -5 of f prime of x dx. So does that make sense to you guys? Because f prime is like velocity, so it's like saying find my position in -5, well, initial position plus the displacement. Don't call it velocity because it's not, right? But it's like, does that make sense to you, Pam, or no? Okay. So here it is, f of 1. What's f of 1? 3 plus bracket. This right here, you're going to calculate it by finding, look, from 1 to 5. Oh, actually, 1 to -5. I'm going to have to, well, I guess I'm going to have to do the -3. Well, that's fine. That's fine. Find this from 1 to -5. So find this area here. And find this area here. Now, both of them are semicircles. Do you guys see that? So from 1 to -3, since I'm going backwards, that's going to be positive because it's below the x-axis, but I'm going backwards. So I'm going to go pi times my r. The radius of that is, does it look like 2 to you? So 2 squared divided by 2. And then this area here for this semicircle, let me turn it to burnt orange. That one's going to be negative because it's above the x-axis, but I'm going backwards. Does that make sense? What do you got there, Ariano?
Oh, I brought this for you.
Did you really? Yeah. You're so kind, miss.
You're so fake. I didn't think you liked it.
Minus pi times, thank you, miss. I'm going to eat it right now. 1 squared divided by 2. All right. If you're scared, well, no, we need to figure out what that number is. I was going to say if you're scared, you can leave it like that, but we need to figure it out. We need to figure this one out. So let's see. 3 plus, this is going to be 2 pi, and that's going to be half pi. 2 pi minus pi over 2, that is 3 pi over 2. 3 plus 3 pi over 2. So some positive number there. 3 plus 3 pi over 2. All right, you guys ready to do this one over here? All right, so there we go. We got that one and that one. Now I need this one. F of 5 equals f of 1, which is 3, plus antiderivative of from 1 to 5 of f prime of x dx. So here it is, 3 plus bracket. So now I'm finding this from 1. This is a little triangle, a big triangle, and a little triangle. We can do that. Hey, Miss Kyle, pick up one of these so you can have fun during the break.
Okay.
I'll upload it tonight.
Okay.
All right, so check it out.
Okay.
It's just one. It's just one sheet, front and back. Have a good one, miss.
You too.
How do I find area of a triangle, guys?
Wait, base times height divided by 2.
Okay, this is just base times height. My base, here's 1, here's 4. So this base is 3, and the height is 2. Do you guys see that? 3 times 2 is 6, divided by 2 is 3. It is above the x-axis, and since I'm starting at 1 and ending at 5, it is positive. So what did I say? I already forgot. Is it 3? 3 times 2 is 6, divided by 2, 3. 3. And then this little part is negative, so I'm going to go 1 times 1 divided by 2, so that little part is 0.5. So 3 plus 0.5. Okay, so let's see, what is it? What is this? 3 plus 3 is 6. 6 plus 0.5 is 6.5. 6.5. So I put a 6.5. Say it again. Oh, yes. Thank you, miss. I was about to get it wrong. I'll make sure to note it on my video. It's because, so this is 3 plus 3. So this is 5.5. If you want it, it's right there. It's up to you. You don't have to focus, miss. You can just relax if you want to just relax. No, you're good. You're good.
Are you recording?
Yeah.
Okay, I'll watch it this weekend probably.
Okay. So there it is. So I'm going to put 5.5. Okay. Now you got to know a little bit of arithmetic to see if you can figure out which one's the smaller one. Notice this is 3 plus 3 pi over 2. This is 3. That says 5.5. The smallest number is the one at 1. Do you guys see that? Because this is 3 plus something, and this is 5.5. So what do they want? The minimum value or just find the absolute minimum value? Okay. Min value of 3 at x equals 1. There it is. They wanted the value. And we'll look at the rubric in a little bit. Oh, this is my explanation. A candidate's test is an explanation. Because it's an explanation for global. Does that make sense? You're up? Okay. All right. Ready, Dina? Okay. The function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in the figure. Let g be the function defined, and they give you what the function is defined by. Find g of 3. All right, here we go. Here it is. G of 3 equals integral -3 to 3 of f of t dt. Well, here's f. I'm going to find the area under this curve. 1, 2, 3 from -3. 1, 2, 3 to 3. Do you see that? 1, 2, 3. So we're just calculating this much. Okay. So let's here's the burnt orange equals. So 3 times 4 is, wait, hold on. 1, 2, 3, 3, and then 4. 3 times 4 is 12, divided by 2 is 6. So this is 6, right? And then this is 2. 1, 2, 3, 4. 2 times 4 is 8, divided by 2, that's 4. And this one here, so let's see, that is that guy right there? Let's see what this slope is. That's 1, 2, 3, 4. That's 4, 1, 2. So the slope is -2. So from here to here, so that just went to -2. So there it is. So 2 times 1 is 2. Divided by 2 is 1. So it's 6 plus 4 minus 1. So 6 plus 4 is 10, minus 1 is 9. What do you think? Okay. Are we still okay? On what open intervals between -5 and 4 is the graph of g both increasing and concave down? So this one, g is increasing whenever g prime is positive. G prime is equal to F. Do you see that? And concave down. Well, that means this graph that I'm looking at is G prime. I am concave down whenever G prime is decreasing. So I'm looking for where this graph, the G prime equals F, is above the x-axis and decreasing. So it's this one right here and this one right here. So I'm going to write G is both increasing and concave down on the interval, or intervals, parenthesis, -5 to -3 and 0 to 2, because G prime, which equals F, is positive and decreasing on those specific intervals. Does that make sense? Okay. You must have this. And the reason why that works is because, well, g of x is this expression, so when you take the derivative, g prime is f. See? Okay, well, g prime of x is f of x. You don't have to put the x, but it would be nice if you did. So g prime of x is f of x. So we must put that. And you're cool, that's fine there. Cool or not cool? All right. The function h is defined for that expression. Find h prime of 3. Okay, well, h prime of x is equal to, what rule do I got to use here? What rule? Starts with a Q. Yeah, quotient. Bottom times root of the top, plus or minus? Minus top times root of the bottom. All over bottom squared. Do you see what we did? All right, let's just plug in a 3. H prime of 3 equals 5 times 3 is 15. G prime of 3, we already got that. Well, I think we do. Yeah, we got it right here. G prime of 3, this is G prime of 3. So 3 comma negative 2. G prime of 3 is negative 2. I think so. Yeah. Minus G of 3, and G of 3, we got it over here, is 9 times 5. All over, what's 5 times 3 is 15, 15 squared? Okay. 15 times 2, that's negative 30. 9 times 5, that's minus 45. And I want to say 15 squared is 225. 45, 55, 65, 75, negative 75 over 225. And I know it reduces, but I'm going to leave it. Cool or not cool? All right. Last one. The function p is defined for that. Find the slope of the line tangent to the graph of p at the point where x is negative 1. All right, let me read that again. The function p is defined. Find the slope of the line tangent to the graph of p at the point where x is negative 1. They just want the slope at negative 1. So I'm going to take a derivative. So here we go. When I take this derivative, so I'm going to go, what do they want? To the graph of p. So the derivative of p. P prime of x is equal to f prime, leave the inside alone, x squared minus x times derivative of the inside. So the derivative of the x squared minus x. What's the derivative of x squared? What's the derivative of x? No, you're right. Minus 1. All right, ready for the plug-in of the negative 1? So I'm going to go p prime of negative 1 equals f prime. Negative 1 squared is 1. And 1 minus negative 1, I want to say that's 2. Right? Okay, negative 1 squared is 1. Minus negative 1, 2. Times 2 times negative 1 is negative 2. Minus 1 is negative 3. We're still okay? All right. F prime of 2. I come over here. F prime of 2. Here's 2, but this is F. So I need to find the slope of this line. That makes sense? Well, yeah, it's negative 2 because this is 4 and this is negative 2. So 4 divided by negative 2 is negative 2. So there it is. So I'm going to put here on the side f prime of 2 is negative 2. So here it is. Negative 2 times negative 3. There it is. How do you feel? Good? All right, we're done. Of course. You don't have to ask a question, miss.